Binomial series. This is our new topic, binomial series. We're going to learn that what is binomial series and what are those methods to solve the binomial series problems. We're going to cover almost everything about the binomial series. So let me first go for the introduction. Binomial series is actually the special case of Maclaurin and Taylor series. It is not something different. It is actually the special case of Maclaurin and Taylor series. It comes out of Maclaurin and Taylor series. The word bi means two and nom means term, so a series with two terms only. It's pretty much clear from its name, binomial. Bi means two, nom means term, so a series with two terms only. Binomial series has only two terms. A series with more than two terms is not a binomial series because bi means two, so we're going to take only two terms for the binomial series, not more than two terms. A series with three or more than three terms is not a binomial series. As we saw that bi means two, nom means terms, so a series with the two terms only. But what about the series with the three or more than three terms? It is not a binomial series. A series with more than two terms is not a binomial series. Binomial series has only two terms. Binomial series always converges when x modulus is less than 1, but at the endpoints it depends on the value of k. Look, it is for the infinite binomial series. We're going to learn later that what is the finite binomial series and what is the infinite binomial series. So infinite binomial series always converges when x modulus is less than 1. But at the endpoints it depends on the value of k. Some formulas have k. In some formulas we use n. So it actually depends on the value of k, which is the power of the binomial series. Just keep this in your mind for time being. We're going to do it later. You're going to learn that what is binomial infinite series and how it converges when x modulus is less than 1 and how it depends on the value of k. We're going to do everything later. Just stay tuned. Don't worry. Now let me first show you that how binomial series came out. What is the path from where the binomial series came out? Look, we know that a plus b to the 1 is a plus b. A plus b to the whole squared is a squared plus 2ab plus b squared. A plus b to the whole cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. A plus b to the whole 4 is a to the 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4. Now can I write a plus b to the whole n equals to a to the n plus n times a to the n minus 1 times b plus n into n minus 1 over 2 factorial times a to the n minus 2 times b squared plus n into n minus 1 into n minus 2 over 3 factorial times a to the n minus 3 times b squared plus n into n minus 1 into n minus 2 and so on up to n minus r minus 1 into a to the n minus r times br plus n into a b to the n minus 1 plus b to the n. This is what we call the binomial series. That's how binomial series came out. It depends on the value of n. You can put a plus b to the whole 5, a plus b to the whole 6, a plus b to the whole 7, and so on. So this n can be any number. The bigger you have the n value, the more you're gonna have the terms in the binomial series. Now look, let me try a plus b to the whole squared. By using the binomial series, we're gonna check that whether this left side equals to the right side or not. Look, my n value is 2. So if I plug in n equals to 2 here, I will have a to the 2 plus 2 minus 1 into b to the 1 plus 2 into 2 minus 1 over 2 factorial times a to the 2 minus 2 into b squared. So the moment you get a to the 2 minus 2, you have to stop it. If this number which you subtract from the n equals to the n, then you have to stop the series. It depends on the value of n. So look, by plugging n equals to 2, I will have a squared plus 2ab. Because look, a to the 2 minus 1 is a to the 1. A to the 1 is 1. So I will have 2ab plus 2 into 2 minus 1. 2 minus 1 is 1. So 1 times 2 is 2. I will have 2 in the numerator and 2 factorial in the denominator. 2 factorial is 2. So 2 cancels with the 2. Similarly, I have a to the 2 minus 2. 2 minus 2 is 0. So I will have a to the 0 times b squared. A to the 0 is 1. Therefore, I will have plus b squared. So I got the exact right side by using the binomial series when I plugged n equals to 2 here. I will get a squared plus 2ab plus b squared. Let me try n equals to 3. By using the binomial series, I'm going to check that whether this left side equals to the right side. So by plugging n equals to 3 here, just plug in n equals to 3, 3 here, 3 here. Wherever there is n, just plug in n equals to 3. You have to continue the process until at the moment when you get a to the 3 minus 3. If the value that you subtract from the n equals to the n, like 3 minus 3, then you have to stop the process, which absolutely depends on the value of n. So by plugging n equals to 3, I will have a to the 3 plus 3 into a to the 3 minus 1 into b plus 3 into 3 minus 1 over 2 factorial times a to the 3 minus 2 times b squared plus 3 into 3 minus 1 into 3 minus 2 over 3 factorial times a to the 3 minus 3 times b cubed. So since I got 3 minus 3, therefore I'm going to stop the process here. Well, this will be the terms for a plus b to the whole cubed. Just plug in n equals to 3 all the way and do simplification. At the end you will get a cubed plus 3a squared b plus 3ab squared plus b cubed. That's what you will get if you plug in n equals to 3 here. But make sure you have to stop the process here at the moment when you get a to the 3 minus 3. Now when you look to the series, it starts from a to the n. Whatever value you have for the n, you just put it here for the n. Like we have 4 here, so a to the 4. We have 3 here, so a to the 3. We have 1 here, so a to the 1. For the first term, just plug in n equals to 1, and then plus the same value, and then times a to the n minus 1. Whatever value you have for the n, you just subtract 1 from it, and then times b to the 1. Just for a moment, ignore the b. Let me first pick a. So it starts from n, and then a to the n minus 1, and then a to the n minus 2, and then a to the n minus 3, plus so on, up to a to the n minus r. Look, whatever value you have for the r, which is the factorial value, you have to plug in here for the r. So a to the n minus r. Similarly here, my b is b to the 0. b to the 0 is 1, so normally we don't write b to the 0. So b to the 0, and then b to the 1, we have b to the 1 here. And then b to the 2, b to the 3, b to the 4, b to the 5, b to the 6, b to the 7, up to b to the r. Look, you can add more terms. This n into n minus 1 into n minus 2, n minus r minus 1 over r factorial into a to the n minus r times b to the r means that you can add more terms, which depends on the value of n. The more you have the terms, the more you're gonna have n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, n minus 6, n minus 7, up to n minus r minus 1, which is actually n minus r minus 1. Look, for the fourth term, I have n into n minus 1 into n minus 2 over 3 factorial. My r value is 3. So by plugging r equals to 3, and then when I subtract 1, I will get 2. Therefore, I have n minus 2. The end value is n minus 3. This term shows the in parentheses. For the third term, I have n into n minus 1 over 2 factorial. My r is 2. So when I plug in r equals to 2 here, and then when I subtract 1, I will get 1. Therefore, I have n minus 1. If I have 4 factorial here, I will have n into n minus 1 into n minus 2 into n minus 3. Because for this end parenthesis in the numerator, this end portion must be n minus r minus 1. Whatever value you have for the factorial, you have to subtract 1 from it. That's going to be your end of the parenthesis. Plus n into a times b to the n minus 1 plus b to the n. Like here, it starts from a to the n, and then n times a to the n minus 1 times b. But it ends, the binomial series ends at b to the n. Here we have n into a to the n minus 1. Here b to the n minus 1. Here the power of b is 0, b to the 0, which is 1. Normally we don't write b to the 0 because it equals to 1. Here the power of a is 0. So the power of a starts from n minus 1, n minus 2, n minus 3. Similarly here the power of b starts from 0 and then power of b is 1, 2, 3, 4, 5 until at the point where we get b to the n, which is this n value. Now the best way to clear your concept is just to look it carefully. Just look to it and spend a few minutes. Your concept will be clear. Now can I write that it equals to summation of n into n minus 1 into n minus 2 up to n minus r minus 1 over r factorial into a to the n minus r times b to the r, where r starts from 0 up to r equals to n. It is actually the summation of different terms which depends on the value of n. We just learned this part, that why I wrote n minus r minus 1. Look, this is my personal concept. In some books you may see this part different. You may have plus 1 or something. It will be different. This is my own concept. I just relate this part with a factorial. So it is actually the summation. The sigma means the summation of all these terms, where r starts from 0 up to n. So we can write that this is binomial series. And also we call it binomial theorem. This binomial series is binomial theorem. We're going to use this binomial theorem to solve many problems. That's how this binomial theorem or binomial series came out. You can try for a plus b to the whole 5, for a plus b to the whole 6. You're going to get different terms. So that's what we call it, binomial theorem or binomial series. But in some books or in some resources, the authors write the binomial series in this way. It is absolutely the same thing. It is just a matter of k and n. You just replace n by k. In some books they have written k. In some books they have written n. There is nothing different. There is nothing different between this and this. So whether you use the binomial series with the k or with the n, it is up to you.